This pile of PC components used to be the rather rare Canon A-200EX II. I say rare because I haven't been able to find any information about this machine on Google. In fact, if you Google this PC, you will only find one picture of it, and one video on YouTube. That video is part 1 in this mini-series. If you want to watch it first, you can use the link in the description below. In that video we did a full disassembly and we tried to find what component inside had let go of its magic smoke. Weirdly, there are no visible clues inside the machine, and everything seems to work aside from the hard drive. Since the hard drive is the only faulty part, as far as I can tell, this video is going to be a repair attempt of a MiniScribe 8425. Whether we succeed or not, we will also reassemble this Canon and try it out with some good old DOS game. This Canon came with a hard drive that has a rather intriguing history. MiniScribe Corporation was a manufacturer of hard drives, founded in Longmont, Colorado in 1980. They managed to become a major player on the market, after having won a series of contracts with IBM and Compaq. However, in 1987 the company conducted a quick inventory to estimate its accounts. Unfortunately, their internal inventory count showed that there was a shortfall of between 2 to 4 millions. Instead of reporting this, a number of managers decided to break into the accountant's safe and replace the documents to match their inflated numbers. Later that year, the managers rented a warehouse where they personally packed 26,000 bricks into hard drive boxes and shipped them to Singapore to bolster the inventory count. After the count was complete, they recalled those serial numbers as defective units, and the company continued to post impressive numbers. It's a fascinating story of a company that made one bad decision that snowballed into its final liquidation in 1990. The full story is out of the scope for this video, but you can check out the YouTube channel Tech Time Traveler for an in-depth video. So let's jump over to the workbench and take a closer look at that MiniScribe. Before we do, I'd like to thank our sponsor PCBWay. Aside from making excellent PCBs, they also do CNC machining, sheet metal fabrication, 3D printing and injection molding. Check out their shared projects page, where you will find some really cool projects for your vintage PC. Get an instant quote now at PCBWay.com. Thank you PCBWay for supporting this channel. Okay, let's start with a quick test, because I placed some oil down the shaft of the stepper motor in our previous attempt to revive this drive. So let's push the switch and see if it spins up. And it doesn't. It's quite dead. There are no signs of life whatsoever. Okay, so let's remove that PCB and see if we can help that motor to spin up manually. There are no burn marks, and I can't see any damage to any of the tantalums. We also found some debris on the hard drive that looked like it could have been the guts of an electrolytic cap, but it was a very small piece, so it's hard to tell really, but it sure looked like it. Maybe it slides out, and I think it does, yes. Well, the motor spins freely, and there is some grease residue. Yeah, that motor is definitely not stuck. And I think we have an exposed bearing here, since it's kind of oily. So we could always lubricate it more. But I don't think it's needed. It spins freely, and it doesn't make any weird noises. And we don't have any components on this side of the board. So I can't see anything suspicious on the drive, unfortunately. Well, I guess we could just reconnect the motor with the PCB on its side and see if it moves. And all the other cables are too short. to be a part of this test. So let's try this. Oh, check this out. So now the motor spins up. So it was stuck. Well, that's interesting. I think I'm gonna let it spin for a while before we put that PCB back. So I'm gonna leave it like this for a minute. And if there is some dried up grease, it will have some time to warm up and perhaps start doing its thing again. And I have to say, that is one quiet drive. That is just whisper quiet compared to my Connor drives. Okay, so I left it on for about 10 minutes. Let's turn it off. Well, the motor is still cold. Let's turn it on and off a few times and see if it's consistent. Yes, I think it is. So I'm gonna put that PCB back on and see what it does. Okay, let's put that PCB back in and reconnect that stepper. Yeah, I was really surprised by how quiet that motor was. I think MiniScribe drives weren't that expensive, so I was expecting a cheap and noisy drive. And I guess we better put at least a few screws back on. This PC has had enough of magic smoke. Okay, let's see if it still spins up with the PCB attached. And it does. And here's the stepper motor action. That looks perfectly normal to me. Well, I guess we should try to connect ribbon cables. And luckily they are quite lengthy. So let's see if it boots. Yeah, that drive sounds really good. And we're getting a disk boot failure. Now let's try to boot to DOS on the floppy drive. And see if we can access that drive at all. No, invalid drive specification. So it doesn't recognize the hard drive at all. Now this could be a configuration error. And we might even need some special floppy disk to configure that hard drive for the system board. Now that could be a big problem, because as I mentioned in the intro, there is no information to be found on this machine online. I'm gonna need to do some thinking here. Well, I did some thinking for several seconds and realized that the motherboard has dip switches, so it probably doesn't need a special start diskette to set the BIOS settings. And I checked the dip switch for the hard drive controller, and it was correctly set. So the only clue we have is a tiny piece of debris that looked like it could have been the guts of an electrolytic cap. So that's what we are going to check first. However, I have to say that I find it quite unlikely, because none of the electrolytic caps have any visible damage. But let's check them anyways. And especially these ones that are close to where the motor is connected. Because my guess is that the motor was stuck. And that may have caused some overcurrent on this board and damaged one of the components. And as I mentioned before, something blew inside this PC and the magic smoke came out. But I haven't been able to find where it came from. So this leg is the negative side. Let me see if I can reach that other leg and get this on camera. So we may not get accurate readings since these caps are in circuit, but this should be a good start. We're getting 0.49 ohms. And the meter informs us that it's a good cap if it's below 200 micro. This cap is a 22 micro Nichicon. So for now we're gonna assume that that cap is good. Let's see if we can reach the legs. We're getting 0.97 ohms. And I assume it's the same value on this cap. It is. So that cap is good too. We might as well check the other ones. We're getting 0.44 ohms. This cap 0.96, 0.6 ohms. And the last one is 0.8. So the electrolytic caps on this board seems to be good, at least with the values we get in circuits. And we're not going to trust that entirely, but I think that's good enough for now. Well, another component that tends to blow are the tantalum caps. So let's check at least the larger ones. Although I'm not sure if these small ones are tantalums or ceramics, but these are definitely tantalums. So let's at least check these. And it's really hard to read the value on the components, so let's check them with a meter. And I think this is a 4.7. And we're getting 55 micro, so that's quite a bit off. But let's check it anyways and see what we get. Yeah, these leads really aren't great to check caps on the PCB. We're getting 1.5 ohms. And it's good if it's below 47 micro. And it is. Whether we are getting the right reading or not from the unity. Okay, so down here we have another one. And I can't see the value printed on this tantalum at all. So let's check it. Now that is suspicious. It doesn't seem to be able to read at all. Okay, let's hope for the best. Let's see what ESR we've got. 1.8. So the ESR is okay, but the unity can't read the value. Well, I guess that is our main suspect at the moment. And this is me from the future. For some bloody reason my microphone decided to pick up a high-pitched noise here for a few seconds. I don't know what it is. I didn't have any CRTs turned on. But it will only last for a few seconds and then it will disappear. And those two are the only large tantalums we've got. Yeah, let's lift one of the legs and measure it again. Okay, let's try again. And we're still getting weird numbers. That's a bit strange. Let's remove it and do some more tests. Well, I can't see any damage. Let's do some measurements. Yeah, let's try it out with a component tester. 32 pico. Let me check the value that's printed. Yeah, I checked and that is supposed to be 4.7 micro. So let's check it again. And now the meter thinks that it's a 131 ohm resistor. Yeah, that cap is definitely misbehaving. Let's check it again with the unity. No, it seems to be out of range for this meter. But the strange thing is that we are getting decent values on the ESR meter. 1.8 ohms. Well, we have another one on the board, so I guess a comparison would tell us whether the cap is bad or if I'm not measuring it correctly. So I'm gonna pull the other one off the board and we'll make a comparison. Yeah, this is really not the way to remove components from a PCB. But I'm eager to find out what values we will get. And yeah, so these are identical. So let's check this one again when it's not in circuit. And we're getting the correct reading, 4.7 micros. So yeah, we've got a bad tantalum, but The weird thing is that it doesn't have any damage to it. So it doesn't explain the magic smoke. But we definitely need to replace it. Well, I didn't find any axial tantalums. This one should do. And it's a 4.7, alright. I guess we might as well check the ESR just for comparison. We're getting 1.6. So I guess I'll just bend the leads and make this work. Yeah, nice and bodgy. And I just realized that we have a third tantalum down here. Somehow I missed it. This one too is out of range for my unit T. Yeah, but these values are in circuit, so they are not to be trusted. I guess we need to lift this one off the board as well. And measure again. Now we're getting a correct value, so if that's a 4.7, 5 is close enough. Let me check. Yeah, that cap has the same value as the other two. Let's check the ESR. It's kind of annoying with these short leads. We're getting 1 ohm. So that cap is probably good. So let's clear those through holes out. And I just found some more debris on our board. So where did this come from? And I found it here. So before I move on, I'm gonna double check all the components in this area. Well, I couldn't find anything missing. Tiny piece of black plastic. So not sure where that came from. So let's solder back 2 of the original caps. Then our bodged cap up here. Okay. I guess it's time for a test. Fingers crossed. And the drive still spins up. But we got a disk boot failure. So let's boot to the DOS floppy and see if we can access the drive at all. No, invalid drive specification. So, still not fixed. Well, I just realized that we never checked in F-disk. And we definitely need to. No fixed disk present, so no such luck. Well, let's test some more components. Okay, so I decided to double check the hard drive controller. And I found something suspicious. So this resistor here has burn marks. And the values are completely off. But these are in circuit values, so we're not gonna trust them. Let's get it off that board and check it again. And it has bent legs. How annoying. So let's see what it measures off the board. And it's actually spot on. So it's burnt, but the value is still correct. Well, I guess I'll keep looking. Okay, without any real clues, I'm gonna focus on this area here. Because since that motor got stuck, this is probably the area where things went south. And I'm gonna start with these MOSFETs that are probably driving the motor. And since the motor now spins again, they are probably not dead, but I think we need to check them. And these are a bit funny. Let me refocus. Yeah, they have been soldered pretty poorly at an angle. So let's pop them off and see if they are okay. And these are stubborn little buggers. They sure are not coming off easily. Okay, let's see if we got all the legs freed up. No, this one is still stuck. Let's give it some heat. Okay, that should do. Let's gently pry them off. No, this one is still stuck. Here we go. That's our first. Let's pull that second MOSFET. No, that one's still stuck too. And I'm obviously not going to use any force. Yeah, something is sucking up all that heat. Yeah, this MOSFET needs some help too. Let's heat up those pads. I can't see any solder left in those through holes, but they definitely are still stuck. Let's try again. Yeah, here it comes. And yeah, they look alright. Well, I guess we should test them. Well, the component tester doesn't like this form factor, but we could try to use the pad. And it shows as a small cap. That might actually be the problem with the tester. Let's try the other one. Yeah, same thing with this one. So that might actually just be the internal capacitance of the MOSFET. So that didn't help much. I guess I need to check the datasheet. Okay, so this is what we've got. Let's test them with a multimeter. So, in diode mode, with a positive probe on the drain and the black lead on the source, we should have nothing. And the other way around, it should act like a diode. And it doesn't. Here we got something. That was probably a bad connection. Okay, let's try with these. So, with positive on drain and the black lead on source, we should have nothing. And the other way around, it should act like a diode. And it does. Let's try the same thing with the other MOSFETs. Nothing. Yeah, that's okay. Okay, let's see if it turns on. So let's turn it on. Let's turn it off. Yeah, that seems to be working. Turn on. Yep. And turned off. Okay, so there's nothing wrong with this MOSFET. This one is probably good too. Turn it on. Yep. Let's short it to turn it off. Yeah, these MOSFETs are probably good. Yeah, there's nothing wrong with these MOSFETs. So that was just a bad soldering job from the factory. Well, I guess in that case... Well, we checked the ESR for the electrolytics, but we didn't check if they were out of spec. And this tantalum that we replaced actually had a good ESR reading, but it was way out of specification. So I think the next thing to try is to lift one of the legs on all the electrolytics and check the values. And also, since this board released its magic smoke and didn't leave any clues, I'm guessing that under one of these components there is probably a tiny hole where the magic smoke came out. Yeah, I think this is a good test. Okay, all the electrolytics are raised. I guess we will start with an inspection. That one looks good. Let's check underneath this one. Yeah, that looks good too. This one looks fine. This one too. Then we've got these two. Yeah, no cracks. No holes. No burn marks. And I can't see any burn marks on the PCB either. Okay, well, let's check the values they have. I think they are all identical. 47 micro, 22 micro. No, they are not identical. So this one is a 22. And it's reading 22. That's spot on. Well done, Nichicon. This one is 47. 45. That's good enough. This one should be 47 as well. We've got 45. This one is 47 as well. We're getting 45. This one is 22. And it's spot on. And the last one is a 22. And it's 21.7. Crap, so the electrolytic caps are good. Well, at this point, it could be just about anything. I'm completely out of clues. Everything seems to be within specs. And motor spins and the stepper moves, so we've got the basic functionality. So it's not something simple. And we have no visual clues. And this video is probably getting lengthy. I mean, I guess we could just check random components, like diodes and resistors and whatnot. Damn, this is a tricky repair. Okay, so I'm running out of time here, so I checked all the transistors and diodes off camera. And now I only have about 1 minute left to spend on this video. So let's check the remaining caps for dead shorts. And again, I'm not sure if these are tantalums or ceramics. They are a bit weird. Okay, so I'm probably gonna fast forward here. But I couldn't find any dead shorts on any of the remaining caps. So none of the caps on this PCB are shorted. Well, I guess I might as well just check quickly if we have a dead short across any of the resistors. Well, in that case, it's time to move on to the reassembly. Here is where things got from bad to worse. This bloody Canon had some more racket in storage for me. Apparently I had not had my share of magic smoke for this week. My game collection for MDA graphics is very much unexisting. So I decided to bring out my Christmas present, the highly sought after IBM 5154 EGA display. You have probably already guessed what happened next. I didn't have the camera on, so unfortunately I can't offer you the sound of crackling electronics. But I was quick enough to turn the camera on to capture the magic smoke escaping. Well, that MiniScribe was a bit of a disappointment, but I have not given up yet. If you have any suggestions for things to try out, please feel free to share. Apparently there will be a repair video of an IBM 5154 display on this channel soon. So now would be a good time to ring that bell below if you want to see that video. As for me, I'm gonna go and grab a bottle of wine now and try to laugh this whole project off. Thank you for watching. If you want to support this channel, like, subscribe, leave a comment and ring that bell below.